Alright folks, today we're working on 10.1.b, which is geometric sequences. This is the second major kind of sequences. And remember, last time we had arithmetic sequences, which is where you add or subtract the same amount of time. We'll talk about what geometric sequences are this time. In addition, we'll also talk about how to find some missing parts of them. So we got two goals. One, we're going to use the geometric sequences to solve for some unknowns, and part two is we're going to find some missing terms. So, a bunch of y'all play the game 2048, where you must match similar tiles to double their value until the player earns a 2048 tile. The starting tile for 2048 is 2. So we're going to simplify it a little bit and just say, look, we're concerned if people play a perfect game. So part A is asking, how many levels of matching tiles must happen for the player to reach 2048? So if we know the starting tile is 2, that says a sub 1 equals 2. So if we say our n is the number of matches we have to make, our a sub n is the number they have when they're matched. So the first one, our first one we come out with is a 2. We say they double their value. That says we're going to multiply by 2 every single time. So our second one, our 2 becomes 4. Our third one, our 4 becomes 8. Our fourth one, our 8 becomes 16. Our fifth one, 16 becomes 32. Sixth one, 32 becomes 64. And yeah, we know there's a bunch of them that you have to match up on the inside. We're looking for just how many levels of matching tiles you have to get. So 2 4s give us an 8. 2 8s give us a 16. 2 16s give us a 32. And so on and so forth. 7th level, we're going to have 128. 8th level, 128 times 2 is 256. 9th level, we've got, let's see, 256 times 2, breaking out my calculator now. I think it's 1024, or, oh, nope, forgot 512. 512. 10th is going to be 1024. That says the 11th level is when we get 2048. So yeah, there's a bunch of them that have to go into this 1024 again. But the 11th level is going to give us 2048. So, after 11 levels, or maybe so not after, let's say at 11 levels, the player wins. Okay, so here's the other thing we got to talk about. Our pattern here, right? We're multiplying by 2 every single time, and you can find that by taking any, so our common ratio comes from our nth term divided by our n minus 1th term. So for example, if we wanted to use 2, so we would say a sub 2 over a sub 1 is going to give us 4 over 2, which is going to be 2. We can do the same thing over here. If we wanted to use a sub, I don't know, 8, right? Over a sub 8 minus 1 is a sub 7. That would be a sub 8 is 256 over a sub 7 is 128, which is, so 256 divided by 128 gives us 2. So that common ratio, which they're going to talk about, and we'll talk about in just a second, is to just take any of the two of them, the second one, or the further one divided by the previous one, the further one divided by previous, further divided by previous, further divided by previous, and you're always going to get 2. This is the definition of a geometric sequence. Only when you multiply by a common factor will it happen. And remember, division is actually multiplication. So like dividing by 2, same thing as multiplying by 1/2. So if you see division by the same thing, it's really a geometric sequence. Okay, so let's talk about this thing, recursive, to model the scenario. So we've done recursive, we did it last time. That just says we have to use the previous term. So use the previous terms, the n minus 1 term, to write the equation. Okay, so we know that the nth term comes from
the previous term and we multiply it by 2 to double it. So we're going to say we take 2 times that previous term gives us this value. So we could test this if we wanted to. So if we were looking for like a sub 10, right, we'd say 2 times a sub 10 minus 1, which is a sub 10 times 2, or equals 2 times a sub 9, which that would mean that a sub 10 equals 2 times a sub 9 is 512, and we get 2 times 512 is 1024, which is what we had predicted up here as well. So yeah, that works out.
Okay, so this is our recursive formula because it uses the previous one. Okay, so when they say write an explicit formula, they're asking for, we don't want to use n minus 1, we just want exactly what it is if we just plugged n in. So we go to our formula sheet over here, and we look for the term geometric sequence, which there's arithmetic sequence, arithmetic series, we'll talk about that next. Geometric sequence is right here. A sub n equals a sub 1 times r to the n minus 1 power. So we need to write down our formula. So a sub n equals a sub 1 times r to the n minus 1 power. And you can choose to put that r in parentheses if you'd like to, like this. Remember, a sub 1 is just our first term. We talked about that up here. So a sub 1 equals our first term value. Remember, r is our common ratio. And it says all of this to the right side. So a sub n is the nth term, so we put a 1 there, that's the first term. Our r is our common ratio, and n is, don't forget, the number of term. And n kind of acts like x, and then it's our input value for an explicit formula, and a sub n kind of acts like y. So let's write in what we know. We're going to keep our y here, so we're going to keep our a sub n equals, we need to substitute in our first term value. Our first term value is 2. Our common ratio, which we've calculated a couple times up here, is 2. So 2 times 2 to the
n minus 1 power. Okay, that's our explicit formula. And we could check this just by plugging something in, right? So let's plug in 10 again, why not? So a sub 10 equals 2 times 2 to the 10 minus 1 power. So a sub 10 equals 2 times 2 to the 9th power. So I'm just going to plug this in my calculator at this point. 2 times 2 to the 9th power. And you could put parentheses around this one part if you want to. 2 times 2 to the 9th is 1024. You can also do 2 times 2 to the 9th is 1024. Regardless, you need to take care of your exponent stuff first if you don't have a calculator to do the order of operations for you. So we do get 1024. Okay, so this explicit formula works. All right, so let's look at part D. Use the explicit formula to find the number of levels of matching tiles needed to earn the 32,768th tile. So that says, let's see what we know. We know our a sub 1 is still 2. We know our common ratio is still 2. We don't know the number of tiles, though. That's a question mark. But we do know the final value. That's our 32,768 numbered tile. So let's use our explicit formula like it says. So a sub n equals 2 times 2 to the n minus 1 power. We know a sub n. It's 32,768 equals 2 times 2 to the n minus 1 power. So what we need to do is we need to figure out how to get this by itself. You know, this reminds me a lot of exponentials from our last unit, because we have stuff in the exponents up here. So this is 2 times stuff, so let's divide both sides by 2. We're going to cancel this 2 out. We can't cancel the one that has the exponent. So we're left with 2 to the n minus 1 power. So then 32,768 divided by 2 is 16,384. Oops, forgot my comma. So I have something to an exponent equals a number, which I solve exponents using logs. So log base 2 of 16,384 equals our entire exponent n minus 1 power. So I'm going to write the whole thing over on the right side. So we can solve this using the change of base. Do more work over here. So do log of 16,384 over log of 2 equals n minus 1. So let's type that in. So log 16,384 divided by log of 2, and that's going to give us 14 equals n minus 1. We don't want n minus 1, we want n plus 1, or n by itself. So let's add 1 to both sides. So we're going to get 15 equals n. So that says at the 15th layer, or maybe level of matching, the player earns the 32,678th tile. We get
32, 768, which is really hard on that 4x4 square. I know I've gotten better than 1024, but I have not gotten anywhere near 32,768. Okay, so we've got one more thing to look at. We need to figure out one more thing that has to do with when we have some missing terms, and this is not as intuitive. So last year when you did geometry, you might have done something where you found the missing terms in the geometric sequence, or you found a thing called the geometric mean. So we're going to use the geometric mean. I think last year, if you did in geometry, you probably used it to find, like, for a right triangle, you knew this part, it was like a number. You didn't know this part, and it was like a number. And so you set up a formula like x over one of your numbers equals the other number over your x. We're going to do the exact same thing here. So this is asking us to find the missing geometric sequence terms as well as the common ratio. So we know it's a geometric sequence because they told us. So let's see here. Geometric mean. So we need to find our missing terms. So we're just going to set it up using our geometric sequence ratio, or geometric mean ratio. So let's see. So x is our unknown part here over one of our numbers equals the other number over x. And order doesn't really matter here. You could switch these, you'll still get the same thing. You're going to solve this by multiplying by x on both sides. So multiply the x's, you're going to x squared. And by multiplying by 9 on both sides. So 9 times 81 is going to give us 729. So 729, let's see, we got x squared equals 729. Let's square root both sides. So x equals, let's see, the square root of 729 gives us 27. So let's see if we can make this work. So 9 times something gives us 27. 27 times that same something should give us 81. So 27 over 9 is 3. 81 over 27 is also, oh, it is 3. Okay, so it works. So our missing term is 27. Our r is 3. So the missing term 27, our common ratio. So the common ratio, what we multiply every single time by, is equal to 3 as well. Okay, so this works regardless if you have one missing one of them or if you've got multiple missing ones. So we're asked to find if 200 is the first one, we multiply that by something, multiply it by something again, multiply it by something again, we multiply it by something again, we get 12.5. So there's a couple different ways we can do this. I like to use the geometric mean. So this one gives us the middle term out of each of our endpoints. So if we use the missing term on 212.5, we're going to get our number right here in the middle, which we could then use again to find either of these two other ones. So let's do that. So we're going to say x over 200 equals 12.5 over x. So we get x squared equals, let's see, 200 times 12.5 is 2,500. Square root both sides, you're going to get x equals, let's see, I'm pretty sure it's 50 off the top of my head. Calculator also tells me it's 50. So that says this middle term right here is 50. So that's the work for this one is right here. But we need to find all the missing terms. So now we need to do the geometric mean again on these two to find the middle one, and the geometric term on these two to find the middle one as well. So I just wanted to explore a different way of solving for one of these in case you were interested. We know that 200, right, times a ratio times the ratio again is going to equal 50. So you can also solve the problem like this. So where you would say 200 times our ratio that we don't know times our ratio again that we still don't know equals our next term. So we would say 200 times r squared equals 50, which then we would divide both sides by 200. So r squared equals, let's see, 50 over 200 is actually 1 over 4. We take the square root of both sides. We find our common r, so the square root of 0.25 or 1/4, however you do it, is 1/2. That says our common ratio is 1/2. So we could actually just use the fact that we find the r and just multiply it all the way through. Or we can still find a geometric mean, whichever you want to do. So 200 times 1/2 is going to give us 100. So let's check to see if we get 100 using the geometric mean. So x over 200 equals 50 over x. We're we get x squared again times, let's see, 200 times 50 is I think 1,000? No, it's 10,000, missed a 0. 10,000, square root both sides, we're going to get x equals, let's see, square root of 10,000 is 100. So yeah, we get 100 like we thought we were going to get. And then the last one, we can say 50 times 0.5 or 50 times 1/2 again, but I'm just going to practice one more time. So this one is this work right here. I'm going to practice one more time with the geometric mean just to show you how it's done. So x over one of my numbers equals 12.5 over my other number. So x times x is x squared equals 50 times 12.5. which is 625, and I actually know the square root of this off the top of my head. It's just 25. So we get 25 here, which makes sense. If we have an r of 1/2, 200 times 1/2 is 100, times 1/2 is 50, times 1/2 is 25, times 1/2 is 12.5. And again, if you didn't think about this, you could still say, oh, 100 over 200, or you could say 50 over 100, or you could say 25 over 100, or sorry, over 50. A little bit of a righto there. Or you could say 12.5 over 25. Either way, you're going to get 1/2 as your common ratio. So the common ratio for this equals 1/2 or 0.5, whichever way you're happier with. Okay, folks, I know this took a little bit of a video. Make sure you go back and get anything that you didn't get. Make sure to slowly scroll up on this page. Make sure you get all of example 2, all of example 1. And I'll scroll from top to bottom on the first page so that you make sure you get all of this as well. Make sure you ask any questions if you need to. Other than that, let's get our geometric sequence practice done, and that way you can take your geometric sequence quiz.